Hey guys, what's happening? I'm going to run through problem number 8. Here we go. Alright, first question says, at which labeled points is f prime positive? Well, we're given a graph of f. So remember, we have to relate all the questions back to that graph of f. So if it says f prime positive, I need to think, how does that relate to f? Well, when f prime is positive, f is increasing. So f increasing. And at which points is f increasing? So let's make little tangent lines. Boop. Looks like at A it is. Boop. Looks like at B it's decreasing. C we're still decreasing. And D we're increasing again. So my increasing points were A and D. Alright, and the reason is because f is increasing at those points. Part B says, between which pairs of labeled points does f have a critical point? Well, critical points happen at two places. Oops, there we go. And those are when f prime equals 0 or when f prime does not exist. Looking at this graph, there's no place where f prime is not going to exist because there's no sharp points. So I'm really just looking for where f prime equals 0, f prime equals 0, and those points are going to be where we have our horizontal tangents. So we'll have a horizontal tangent between A and B, and another one between C and D. A and B. Sorry, it looks kind of funny. And hit a button. Crap. There we go. And C and D. That's supposed to be an and. My wife won't buy me a new iPad. Alright, between which pairs of labeled points is f prime increasing? Alright, so again, we got to relate it back to the graph of f. When f prime is increasing, f is concave up. F concave up. Oh yeah. So where's f concave up? Well, I would say it starts somewhere about here and goes through there. So between which pairs of labeled points? Maybe I'll say between B and D because it extends a little farther than point C. So alrighty, and the last question says, between which pairs of labeled points does f prime achieve its minimum value? And hopefully we kind of remember that we saw where f prime has a max or min is where we change concavity. That's where we had that inflection point. And if we're going from concave down to concave up, that would be a relative minimum for f prime. So it's going to be on our graph of f where we go from concave down to concave up. And we just talked about how that was somewhere between B and C. So between B and C. And if you want to think about like your tangent lines and stuffs, we could think that our tangent lines were decreasing because we have a positive, a 0, and a negative. So our tangent lines were decreasing, and then at this point right here between B and C, they stopped decreasing and started increasing. It's still negative, then it becomes 0, and then positive again. So that's going to be that magical place where f prime achieves its minimum value, also known as your inflection point.